So coming round is a sheet that is literally exactly the same as what is on the board, okay, what is on the screen, okay? So along the bottom you have the different hospitals, and along here you have got the survival rate, okay? It's just along here I've just numbered them as X1 through to X13, okay? And each one of these represents each different point, each different hospital. Okay, are we missing any sheets? Has everybody got one each?
Yep, there's one.
Have mine. There we go, okay. Yeah, I didn't print enough off, but that's fine. Okay, fine. So each one of these data points represents the survival rate of a different hospital. So you're happy? What you've got in front of you is exactly the same as what's on the screen. Happy with that? Okay. Now, one way that I could interpret this is by thinking in terms of the average, okay? So if I think about the average survival rate is just below 98%. Can you see that on the screen? Can you see that on the screen? Okay. I think in this case I've just used the mean because actually there's no outliers there and it's relatively easy to calculate. Okay. So could you do exactly the same as what I've done on the screen? Could you find the mean? Could you find the mean? So what is the mean survival rate? And then could you draw a horizontal line to represent the... Has anybody got an answer for the mean survival rate? 97.9. Okay? Now just be aware of notation here, okay? You've got the idea in your head, but how is it actually written down like a formula or something like that, okay? You notice that I've just basically numbered each data point. So I've called this data point 1, data point 2, data point 3, etc., okay? And I've also given it a letter, so I've called it X. Now X, in this case, what does X represent? So X represents each individual hospital, doesn't it? Yeah? So it's the survival rate of each hospital. Okay? So X1 would be hospital 1. X2 would be the survival rate of hospital 2. X3 would be the survival rate of hospital 3. X4 would be the survival rate of hospital 4, and so on and so on and so on. Does that make sense? Okay? Which means if I want to talk about the mean survival rate, the way which I would write that is with an X represents each individual hospital, and a bar over the top. So X bar represents the mean survival rate of my hospitals. Does that make sense? Okay? And how do I work out the mean? How do I work out the mean? Sorry?
The total survival rate.
Yes?
Minus the total hospital.
Good, absolutely. So I literally add together each individual survival rate of my hospitals. So I sum together each individual X, X1, X2, X3, X4, X5, etc., etc., etc. Okay? And I divide it by the number of hospitals which I have. Okay? To be formal here, I should really put a little subscript down here to tell me which hospital I'm talking about. So X is an individual hospital. I'm just going to put a little I to represent either the first hospital, second hospital, third, fourth, fifth, whatever hospital I want to look at. Where am I going to start at? Well, I'm going to start at the first hospital. So I'm going to start my summation at 1. And then I'm going to keep going, so I'm going to keep adding together hospitals until I get to N, the end hospital, in this case 13. Does that make sense? Yeah? So if you see this notation, don't worry about it. It just simply means add together all of the hospital survival rates and then divide by the number of hospitals that you've got. Okay? And X represents the survival rate of each hospital. Is that okay? Yeah? Good. Fantastic. So now you've done that, and hopefully you've got a diagram that looks something like this. Okay? Would you be happy, so if you look at the screen, would you be happy that half of the hospitals are above average? They've got above average survival rate. They're in the good. Okay? They're the good hospitals. But then equally, half of the hospitals are below average, which means that they've got a lower than average survival rate. Okay? Now, is this necessarily a surprise? So is it a surprise that half of the hospitals are good hospitals? Okay? They've got above average survival rate. And half of the hospitals are bad hospitals. They've got below average survival rate. Is that a surprise? Huiji, you're shaking your head. Why?
Upper race must be halfway, so this should be half good and half bad.
Exactly. The average should be somewhere in the middle. Should be somewhere in the middle. We've seen that. Okay? So actually, it's completely normal to have half your data above average and half of your data below average. So what you could say, for example, if you were Newcastle Hospital, I think that says Newcastle, okay? If you were Newcastle Hospital, you could say, we've got above average survival rate. But then that's not necessarily a surprise because it just so happens by pure chance, you're in that 50% that's above the average, okay? If you're 50% which is below the average, that's again just pure chance, okay? So actually just purely talking in terms of averages, not necessarily enough anymore, not necessarily enough. What we need to talk about instead is this idea of spread, okay? So we've got one measure of spread, we've got the range. We've got the range, okay? We've got the range. So what we could say then, is what is the average spread, okay? So by average spread, what I mean is if I look at the distance between, say, this hospital and the mean line, the expectation line, okay? And I do this for every single hospital, I could measure each of these individual distances. In fact, could you do that for me? So could you go through and for every single hospital, work out how far it is away from the mean line, from the expected survival rate, okay? So literally go through and calculate the distance. Okay, so has anybody got a number for the average spread? 0.8, okay? So what you are saying is that given this data, you expect that each hospital should be about 0.8% away from the true expected value, okay? So you expect the mean survival rate, you expect the survival rate to be 97.9%. But then you're also saying that on average, each hospital should be about 0.8% above or below that expected survival rate. So actually the true kind of range which you should be looking at is anywhere between 97.1, in other words 0.8 back, and 98.7, in other words 0.8% forward. So actually you've then got yourself a little interval. So you're saying most hospitals will lie between that range, okay? Will lie between that range. You've got a measure of spread then. Does that make sense? Yeah? So you're basically saying if you take 97.9% as your average or your expected survival rate, if you go 0.8% back, remember that is your average spread, okay? You're basically saying anything from 97.1%, if you then go 0.8% forward, up to 98.7%, okay? Anything between these two values, that is kind of a good representation of what the survival rate would be, okay? And as you can see, most hospitals will lie between 97.1 and 98.7, okay? So if you want to sort of talk about above sort of poor hospital or a good hospital, if it lies outside of this range, then you can start to make that inference. You don't have to do the negative. So this is exactly my point which I want to talk about. Let's assume it's 0.8. It might be something different. Did anybody else get anything different?
Yeah, I got like 0.02, but because I added the negatives to them.
Okay, so that would be the wrong way about going things. Okay, and I'll talk about that in just a second. Are you happy how we calculated the average spread? What we literally did is we took the average of all of these distances. So in other words, we did the sum of the distances divided by the number which we had. Okay, literally just took the average of the distances, right?